This video is for review quiz 1.5, which is on quadratic equations. This first one we see we have just a bunch of variables here. Let's expand the parentheses and see what we get. So the first thing I'm going to do is just FOIL out the right-hand side. 5x times x is 5x squared. 5x times negative 1 is 5x. 4 times x is 4x. And 4 times negative 1 is negative 4. Now I can combine like terms. That gives me 5x squared. Then negative 5 plus 4 is negative x, just negative 1x or negative x minus 4. This is a quadratic because we have the x squared term. And we're going to get everything over to one side so that we can solve it. So I'm going to add the 21x to the right-hand side and subtract the 21 to the right-hand side as well. That gives me 0, which you must have on one side of the equation. And then 5x squared plus 20x minus 25. Here you can see that we have a quadratic that's equal to 0. So we can solve this using any method that we want. But the first thing I notice is that this can be, I can take out a 5 from this. So I'm going to do that, take out a 5. It gives me x squared plus 4x minus 5. Now it's much easier to factor. I can use the AC method. A times c is going to be 1 times negative 5, so negative 5 plus 4. Two numbers that multiply to give negative 5, add to give positive 4 is going to be negative 5 and positive 5 and negative 1. That gives me negative 5 when I multiply and adds to give positive 4. Because a is 1 here, that means I can immediately factor this thing down into x plus 5. That's from this first number. And x minus 1. That's from the second number. Okay, this is in completely factored form. That's what the first part of this question is asking for. X minus 1. And the solution set, at this point, really this 5 doesn't matter. You can divide out the 5, and 0 divided by 5 is 0. And now I have 0 equals x plus 5, x minus 1. That gives me x plus 5 equal to 0, x minus 1 equal to 0. And I can just solve for x. That gives me my solutions. X equals negative 5 and x equals positive 1. So negative 5, comma 1. That's correct. All right, the square root property is a nice property to use. It doesn't require any factoring. It's actually much faster than that. But it requires a very special setup. And this is already set up the way we want it. We want to have this whatever x variable on the one side squared. So this is set up the way we want it to, and so the square root property works out nicely. So what I'm going to do is I'm going to first divide out this 2. We don't want anything with the linear factor that's being squared. We want just the x plus 1 by itself. So we have x plus 1 squared equals 36 over 2 is 18. And now we can take the square root. That's what the square root property means. So take the square root of both sides. That gives me x plus 1. Really, the parentheses don't matter here because this square root and the square cancel, leaving us with just x plus 1. And the square root of 18, I can reduce that. 18 is 3 times, 3 times 6. 6 is 3 times 2. I've got a pair of 3's in there, so I can take a 3 out, and a 2 remains on the inside. So I get 3 root 2. Whenever you take a square root, I should also mention this, you must add a plus or minus in front of it. That's because there are two answers here, the positive and the negative. And whenever you square anything, the positive and negative will always become positive because negative times negative is positive and positive times positive is positive. So we must include that in our thinking when we solve this problem. This is what gives us two answers, and you should expect two answers. This is going to be a quadratic. If you were to expand the x plus 1 squared out, you'd get a quadratic. So you must have two answers. And the plus or minus is what gives us it. Now I can solve for x by getting it by itself. I'm going to put the -1 in front of the radical. Just makes it nicer to look at. And this is my solutions, or are my solutions. So we have -1, and then they have a plus or minus button there for this exact purpose. 3 times the square root of 2. And that's correct. So make sure you get the group that's being squared. Make sure you have that by itself. If I just took the square root of this thing right off the bat, that 2 in front would be it would be square rooted as well, and it would make things more confusing. So it's better to get the x plus 1 squared by itself first, and then take the square root. All right, quadratic formula, a very important formula to have. If you don't remember it, just look it up. And for quadratic formula, we have to have it in the form of ax squared plus bx plus c equals 0, which we already do. And for our quadratic here, a equals 1, right? This is just the number in front. B equals -12, and c equals 72. Now I can plug this into the quadratic formula, which is -b plus or minus the square root b squared minus 4ac all over twice a. So just plugging in those numbers in here to give us our solution. Let's see, we have negative of -12. That gives me +12 plus or minus b squared is -12 squared. That's going to be 144. It's positive. And then 4 times a times c. 4 times a is 4 times 1, so that's going to be 4. And 4 times 72, I don't know that off the top of my head, so just use a calculator. 288. All right, all over twice a. A is 1, so 2 times 1 is 2. Now I can simplify this statement down. 12 plus or minus 144 minus 288. That is -144 over 2. We have a negative underneath of a radical, which means we need to take it out as an I. We'll just take the negative on the outside as an I. And the square root of 144 is 12. So we get the square root of 144 is 12. I'm going to write the 12 in front of the I. This is the standard form of how you write complex numbers. It's going to be a plus bi. So the number goes in front of the I, not behind it. I just rearranged that just for clarity. Okay, and this can be simplified down into 12 over 2 plus or minus 12 over 2i, which of course is just 6 plus or minus 6i. So there are the complex solutions. We have 2 of them, which you should expect. And that's correct. All right, the discriminant is a part of the quadratic formula. In fact, the discriminant, let me get rid of these those highlights so I can show this. The discriminant is just the thing underneath of the radical. And this part is what will determine if we have 2 real solutions, 1 real solution. If it equals 0, we have 1 real solution. And if we have complex solutions. If it's negative, then we have a negative underneath of the square root, and therefore a complex solution. So the discriminant really tells us what kind of solutions we have. And it's quite easy to compute just by looking at the quadratic. Make sure it's in the form of ax squared plus bx plus c equals 0, just like you would for the quadratic formula. And all you have to do is calculate b squared minus 4ac. That's the discriminant. That's what it's called. Okay, we have a equals 3. I should have done this before. B equals -1, and c equals 3. Okay, so b squared is -1 squared, so -1 times -1 is +1, minus 4 times a. 4 times a is 4 times 3, so that's 12. And then c, so 4ac is 4 times 3 times 3. So that's going to be 36. And this equals negative 35. Because this is negative, it's less than 0, this is going to give me 2 complex solutions. That's because we're going to have the square root of negative 35 plus or minus, and then it's going to be negative b over 2a. And this is going to come on the outside as an I. So we have 2 complex solutions. And what is the discriminant? We have negative 35. That gives me 2, it says imaginary, it should be complex solutions, but that's what it says. That's correct. Okay, for this next one, same question. What's the discriminant? So we're going to do the same process. It's already in the correct form, ax squared plus bx plus c equals 0. A is 1, b is negative 20, and c is 100. So we have b squared minus 4ac. That's what we're going to plug it into. B squared is negative 20 times negative 20. That's going to be positive 400. Then 4 times a times c is going to be 4 times 1, so 4 times c is 400. And now you see we have 400 minus 400 is 0. And if the discriminant equals 0, we have negative b plus or minus the square root of 0 over 2a. That's the quadratic formula. This just simplifies into negative b plus or minus 0 over 2a. But plus or minus 0 is the same thing as just an answer itself. And so now we lose one of the solutions. The plus or minus goes away because plus or minus 0 is just negative b. There's nothing else that you're adding or subtracting. So we actually lose a solution. It's not really losing it. We just have, it's called multiplicity of 2. But we only have one unique real solution. So that is what a discriminant equal to 0 means. And if we had a discriminant of positive, which hopefully this one is, we would have 2 real solutions. Minus 5 equals 0. Okay, and then we have b squared minus 4ac. b is negative 3, so negative 3 squared is 9. 4 times a is 4 times 1 is 4. And then we have 4 times negative 5 is going to be negative 20, but there's a negative already in front of it, so it's going to be positive 20. And that gives me 29. This is a positive answer, so this is the same thing as saying 2 real solutions. That's again because we have something like negative b plus or minus the square root of 29 over 2a. This is just a real number. It's going to be some decimal number that I don't know. So plus or minus this real number, it's just going to be a real number. I say real as opposed to complex. That's what we're dealing with here. So we have 29 is the discriminant, and that means there are 2 unequal real solutions. The plus or minus gives you the 2 solutions, and they're real because we did not get a negative underneath of the square root. So we're good to go there. Those are all the 3 different cases you can have. There's not another one. If it's negative, if the discriminant is negative, you're going to have a complex, like we had up here. If the discriminant is 0, you're going to have 1 real solution. And if it's positive, you're going to have 2 real solutions. Those are the only 3 cases you can have. Okay, solve the equation using any method. In general, if you can factor and solve, it's going to be faster, I think, than the quadratic formula. But sometimes the way it works out, it's just the quadratic formula will always be the easiest thing to do because it's the directly, it's a process that you know how to do right off the bat. So I'm just going to get everything over to one side. I'm going to make sure the x squared is positive. That's why I didn't move it over to the other side. And just set it equal to 0. Now I can ask the question, can I factor this thing with the AC method? A is 1 and C is 30. So we have 1 times 30 is 30. b is negative 10, so we have negative 10. So I need two numbers that multiply to give 30 and add to give 10. So I go 30 is 1 times 30. That's 31 when I add it. 2 times 15, that gives me 17 when I add them. 3 times 10 is 13. 4 can't go in there. 5 can. 5 times 6, that's 11. And now we have 6 times 5. That gives me also 11. So as you can see, I've checked all of the simple combinations that multiply to give 30, and none of them give me what I want. So that means I can stop doing this, and I can start using the quadratic formula. So we have a equals 1, b equals negative 10, and negative 10. C equals 30. All right. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over twice a. Negative 10 is positive 10. Plus or minus negative 10 squared is 100. 4 times a times c is 4 times 1 is 4. 4 times 30 is 120. It's all over 2 times 1, which is just 2. Okay, oh, I forgot the square root. Okay, now we have 10 plus or minus the square root of negative 20. So I know right there that it's going to be complex solutions because the discriminant is negative. Take this out as an I. 10 plus or minus I root 20 over 2. 20 can be reduced down into 4 times 5, which is 2 times 2. I've got a pair of 2's and a 5 remaining for the inside, so I'm looking for 2i. Really, this should be 2 root 5i. That's the proper way of writing it with a plus bi as a complex number. And now I can divide both things by 2, so that's just going to be 5 plus or minus root 5i. There are my two complex solutions, 5 plus or minus, let's see, the square root of 5i. And that's correct. So I would check AC method first, because typically if you can do that, it tends to be faster. But if it doesn't work, you can always fall back on the quadratic formula. It will always give you these solutions to a quadratic equation. Okay, this one needs a little bit of room. Let me give it some room here. Okay, we have a wheelchair ramp with a length of 75 inches. So that's going to be this actual ramp portion, not the length of the whole. You know, that's 72 here. That's the horizontal distance. And we don't know what the vertical distance is. So the vertical distance is this one that we're trying to find. And you can see that this whole thing produces a right triangle. A right triangle, we can use Pythagorean Theorem to find what we need to find. A squared plus b squared equals c squared. These are, of course, different than the a plus b plus ax squared plus bx plus c. They just use a, b, and c to designate numbers. In this case, we can do this however we want. We can say, let's just say that make the 72 equal to b, and then the x will equal a. And then the hypotenuse is always the one opposite the right angle. That is always c. There's no decision there. The a and b can be flipped around, but c must be the one opposite the right angle. Okay, so now we can set up the Pythagorean theorem. A is just x squared, b is 72, and that's mean squared, and c is 75 squared. Okay, this is actually a quadratic equation. We have x squared. I could write out what 72 squared is. I'm gonna need to, I think. So let me just find that. 72 squared. Eight, 4, 75 squared is 5625. This is a quadratic equation, and this one's pretty easy to solve because we have just x squared by itself. There's no other variable in there, which means we can use the square root property. In other words, get it by itself. So I want to subtract the number. And I don't know what that is. 25 minus 5184, 441. And to solve this, I can easily just take the square root. Whenever you take a square root, make sure you add a plus or minus. So we have x squared, or x equals plus or minus the square root of 441. I don't know if 441 can be, I bet that's prime, but I could be wrong. Oh no, it's 21. The square root of 441 is 21. Okay, cool. So we have plus or minus 21. So we have either a plus 21 or a minus 21 for x. Now x, you can see here, is the vertical distance of the height of this ramp. And vertical distance, well, distances in general can never be negative. So we can actually throw out the negative solution, and we can immediately say x equals 21, because it cannot equal negative 21, as that doesn't make any sense for a real world scenario. So it's going to be in inches, because that's the unit that it says there. And it's asking, part B, construction laws are very specific when it comes to access ramps for disabled. Every vertical rise of 1 inch requires a horizontal run of 12 inches. So for each inch you rise, you must run 12 inches or a foot. Does this ramp satisfy the requirements? Well, we can see that by saying 1 over 12, so 1 inch over 12 inches. This is the slope that the ramp must be, 1 over 12. And we also know that we have, in our scenario, we have a rise of 21, and we have a run of 72. So all we really need to do here is simplify this fraction down, because it's 21 inches over 72 inches. Simplify this fraction down and see if it is no greater than the 1 over 12 slope that it says, because it cannot be any greater than that. Okay, I can divide out 3 from top and bottom, I'm pretty sure. 8 times 9, so that gives me 8 times 3, so 24. And if you were to divide this by 2, I'm dividing by 2 for a reason here, you're going to get 3.5, which is kind of weird, but we have 12 in the denominator. And 3.5 over 12, well, that tells you that this is greater than the slope that it needs to be. So therefore, no, it does not satisfy the requirements. It's too much. Vertical rise to horizontal run is greater than, this one isn't correct, because it says the ratio of the vertical rise to horizontal run is less than 12 over 1. The vertical rise is the 1. The horizontal run is the 12. So it's flipped. This ratio is flipped. So C is correct, because vertical rise corresponds to the 1, and horizontal run corresponds to the 12. That's the right way that it's supposed to be. So check out, and that's correct. Okay, last problem, we have a pool measuring 18 meters by 30 meters is surrounded by a path. So this like kind of tannish orangish thing, that's the path around the pool. That's what we're trying to figure out. What should the width of that be to satisfy the rest of the requirements? We already have a pool that's 18 by 30 meters. And the area of the pool around is combined. No, the area of the pool, so the area of this blue, the pool, and the width, the path, is supposed to be 1900 meters. So that's what we're trying to fit it into, is the 1900 meters. I'm trying to figure out how big should we make the path around it to fit that nicely. And you can see that it already gave us the side dimensions. Probably a different problem would make you find those things. It's not hard to find those. But this is just, this length here is just the pool, I should say pool width. The pool width is 18. And then we have a uniform path. So it's going to be x wide all the way around, no matter if it's the length or the width of the pool. So 18 plus x gives us 18 plus 2x. That's where this number, this expression comes from. And then 30 is the length of the pool. And then we have an x width for the path, x width for the path. So we have 30 plus x plus x. That's 30 plus 2x. That's the length of the whole area that we're looking at. So really what we have here is 30 plus 2x times 18 plus 2x. 30 plus 2x is the length of the total area of the pool and the path. And 18 plus 2x is the total width of the pool and the path together. And that's the total area. And it said the total area must be 1900 square meters. So this must equal 1900. And you can see that this is really just a quadratic equation. So let's distribute this thing out and see what we get. We get 30 times 18. Let's use a calculator for that. 540 plus 60x plus 36x plus 4x squared equals 1900. And now we can combine like terms. I'm going to move the 4x squared to the front. 60 and 36x is 96x. And then the 540 is near the end. And to solve a quadratic equation, we want to get it equal to 0. So I'm going to subtract the 1900 to the right-hand side. Okay, 540 minus 1900, that gives me 1360. Okay, it's set equal to 0. Now you can see that, well, hopefully you can see that I should be able to divide everything by 4. And that's going to make the problems easier to work with because the numbers are going to be smaller. You get x squared, let's see, 96 divided by 4 is 24. 1360, that's 340. Okay, now we can try to factor this thing and solve. So AC method, a times c is negative 340 and b is 24. So let's look at negative 340. Two numbers that multiply to give that. It'll be 1 and negative 340. It's way too high, of course. It's going to be negative 339. I want 24 when I add them, not negative 339. We get 2 times, let's use a calculator here, 170. That's still way too far apart. 3 cannot go into there. 4 can. 4 times 85. We're getting closer, right? 4 minus 85 is negative 81, of course. That's closer, much closer than this 339 was. So we still are too far apart. 5 can. I doubt 5 can go in there. However, 10 can. Right, 10 can go in this because it's got a 0 on the end. And 10 times negative 34, that gives me negative 24. That's almost exactly what we want, but the sign's incorrect. I can adjust for that by making this negative 10 and positive 34, making this a positive 24. And that's exactly what I want. So I jumped from the 5 because I knew 5 was still going to be too far apart. The 4 was way far. And if you increase by 1 on the multiplier, 4 to 5, it's not going to change that much. So I made a bigger jump because I saw that 10 could go into there. 5 times 2 is 10. That's what cued me in. And it just happened to be exactly what I was looking for. So sometimes it can help to jump around, especially if you are still like a ways apart from the correct answer. So it can help just to jump forward a little bit. Okay, so we have negative 10 and positive 34. A is 1 here, so I can immediately factor this thing down into x minus 10, x plus 34. And now I can get my answers. X minus 10 equals 0. x equals 10, and of course x plus 34 equals 0. This just gives me x equals negative 34. And we can immediately exclude this one. That's because distances can never be negative. So x equals 10. If you were to plug 10 into the original, this original problem right here, you'll see that it will in fact give you an area of 1900. Again, let's check it. And that's correct.